Hello. Am I audible?
Hello. A very good morning to all the participants. On behalf of JPR Institute of Technology, I would like to welcome you all to the last day of the hands-on FDP on data science. I would now like to welcome and introduce the speaker for today's session, Mr. Shammy Narayanan, AVP-AI practice. He has worked in companies like Virtusa, HCL, CSC, and he will be talking to us on conventional neural networks. We welcome you, sir, on behalf of JPR Institute of Technology. Before I hand over this session, I would like to make a few announcements. There will be no quiz today at the end of the session. There will be a quiz held tomorrow from 4 to 5 p.m. and those who score above 65% will be eligible for merit certification. Please note, the quiz link will be active only for 1 hour. So all are requested to take up the quiz between 4 to 5 p.m. tomorrow. The link will be shared in Telegram. The participation certificate will be given within a week's time. And due to huge number of participants, it will take time to generate the certificate, so kindly bear with us. And there was some request for the materials. So the materials will be shared through mail. All further updates will be posted through the Telegram group. Over to you, sir.
Sure, thank you. I hope I'm audible.
Yes, sir, you are audible.
Sure. So let me just start with sharing my screen. Okay, just give me a minute. You're able to see my screen?
Yeah. Yes,
Sure.
sir, yes, sir.
Okay, so let's get started. Thanks for the introduction. And this is the most productive usage of time, the 1 week data science, which the institute has taken, right? It's something which will benefit not only in the short term, but also in the midterm and long term, given that we definitely see data science as one of emerging and unavoidable technologies for tomorrow's world. And when I say this, I'm not saying this just because we are in a data science session and we need to speak high about it. But in fact, just to give you some example before we dive into today's session.
Shammy, sir.
Yeah?
Volume, please.
Okay. Is it okay now?
Yeah, super.
Sure. So what I was trying to say is, I'm not trying to speak high about data science just because we are in today's session on that topic, but rather this is one area where we are finding more and more use cases, more and more ways to disrupt the way the business is being done. In fact, even in this difficult times of COVID, last week I just read France. In Paris today, if someone has to travel in public transport, there are strict rules about they have to wear a mask or otherwise they will be fined. And to figure out whether a person is wearing a mask or not in every public bus, that is not going to be an easy task. Policing in this difficult time is not that easy. So what they have done is gotten a image classification algorithm, and that camera is hooked on to every public transport. It will start viewing the pictures, and if someone is not wearing a mask, it will easily tag saying that, okay, this person in this bus is not wearing a mask. And this is something which I just started, I will say, the last couple of weeks. So today, the AI is being used, especially this image classification, in a way which we couldn't have imagined some few years back. And similarly, all major international airports, if you go in today, and if there is a suspicious behavior by any person, immediately this image classification will go ahead and raise a red flag saying that this person is behaving suspiciously. Maybe they are looking around and they carry something and they keep it somewhere voluntarily. And then that feed goes to the surveillance officers who go in and probably check that person to figure out whether there is something fishy or is he genuinely lost. And this technology is again enabled by AI and in specific your image classification. Most interesting thing which I wanted to share is uh, the self-driving car, right? That is something which we have been talking for a very long time. But the way these cars are being designed is in the windshield, they have a camera. So the camera will keep monitoring the objects around the car. If it sees, so assume that the car is uh, halting on a signal. So there is a red signal and the car is halted. And if it sees a cigarette butt, it will understand that some person is walking in and he might soon cross it. So to that extent, image classification has evolved. And this is a field which I will still say will evolve in the next few years, because we definitely see that compared to last year, within a 12 months period, a lot of software changes has happened, a lot of new APIs have come in. And that is the reason I really wanted to appreciate the organizers of this event for taking in data science as a subject and putting in so much of effort in organizing it at such a scale for this entire 1 week. And I'm glad that we are concluding this entire the week's thing with a deep learning segment called convolutional neural network. So the way we will plan out the next few minutes is we will see some of the theory behind how it operates. I'm not going to make it boring. I took a real world example to make it more and more relevant. And then we will jump on to implementation. And within implementation, we will talk about doing it, implementing it in your own machine or your laptop or desktop, whichever you have. Or if you are someone who doesn't have the latest configuration, how do you do it in the cloud? And various ways it can be done. To be honest, covering this entire session within 90 minutes is a daunting task. So I will try to keep it in a lively pace, and we will try to conclude it in that timeline. However, all the code which we will use here, and even the code which I'm referring, I'm making it available to all the participants through my GitHub, and have made it public so that you can go to my GitHub, you can fork it, and you can use it depending upon whether you choose your on-prem implementation or your cloud implementation. My recommendation is cloud is best, but however, if you are not used to the cloud, don't try it, because if you leave something open, if you don't terminate all your resources, every day it will start charging back your credit card. So make a judicious decision based on your comfort level of either using it in your own service or over the cloud. Okay. Hope my voice is now clear, correct?
Yes, sir, clear.
Okay. So the very first question is why CNN? Why not something else? Why not KNN or any other algorithms? Each algorithm in the AI world is specialized for some specific use cases. And for all the use cases which I just told you some time back, like if you want to identify among a group of people who are all not wearing a mask, in fact, you can go to the extent of identifying not only people who are not wearing a mask, but even those people who are not wearing a right mask. Probably they are wrapping a cloth around their nose. That is not a clinical mask. So to do all those things right, today, if you ask me about image classification, the one algorithm which immediately comes to the mind is CNN. CNN stands for Convolutional Neural Network. And the slide, I had this picture of the lion just to give you that impression. In today's world, CNN is the king of image classification. Why I'm stressing the word today is we never know. 2 years down the line or 3 years down the line, AI is so much evolving. Things might change. You might have a variant of it, but as of today, for every image classification, you get into CNN. And even before I proceed, right, anyone getting into the AI world, you need to know that there are major two types of algorithms. One is your regression types, and the other one is the classification types. Regression is where you determine a value. Say, for example, if I want to know whether I can give how much is this person eligible, or whether this person will be able to repay my loan, can I give him a loan or not? To predict a value, you can make use of a regression. But if you want to classify few things, so if I'm giving you a image of a pen, and if you want the algorithm to identify that image as a pen, so that comes under a classification problem. So CNN is a classification algorithm, and it is used for image classification. But loosely, I have also seen it being implemented to classify and to understand the various musical notes as well. But that is a very in-depth uh, experimentation of it, so we will not touch upon it. But from an academic perspective, it is not only used for image, but also get onto the musical level. Now in front of you in a slide, you do see three animals, right? Or three animals or three objects technically in a picture. And if I have to ask you, identify it, then probably it will look like we have gone back to our KG session, wherein this is one of the exercise. So without putting even enough effort, subconsciously we easily see that from the left to right, it is a zebra, it's a giraffe, and an elephant. It it is something which comes very naturally to us. Now, if I show you a different slide and ask you to identify the animal in the same picture or in the slide, again, without any effort, you will easily say that this is all an elephant. But compared to the previous slide, if you really see, in this slide, I had elephants in different poses. So the first pose was front view, which was zoomed in. The second was a side pose. The third one is little distorted. Probably it was taken in a morning where it had a lot of fog. But our human brain, in spite of all this distortion of the image, changing of the angle, we never experienced a trouble in saying that this is an elephant. We never even had a second thought. The reason behind that is human mind doesn't save an object in its in the fullest form. So what I mean by that is you don't capture an image of an elephant, just save it in your mind, and whenever your eye sees an elephant in the same angle, in the same size, you don't say that it is an elephant. Even when it is in the side picture, a front picture, a zoomed in, a zoomed out version, or a distorted version, you will always be able to say this is an elephant, because The way human mind stores an information is it tries to save the features of it in different parts of the memory rather than storing the whole picture as such. So what I mean by that is, if I go on to the next slide, this is a Wikipedia definition of an elephant. So an elephant definition says it has huge head, it has a columnar leg, it has wide flat ears. So basically something like this, what you see on the screen. So these features are stored in your mind in different location. So as soon as your eye sees an elephant, you try to identify those features of it, whether it has a columnar leg, whether it has a huge trunk and wide flat ears, even the color of the skin. And then what you do is your mind tries to put together all these features and then it recognizes it as an elephant. All this is done in a time of less than a second. So you don't even recognize the speed at which your mind is processing the entire algorithm. And CNN tries to do the same thing. So it doesn't try to do a pixel to pixel mapping. So if you see the slide which I have shared, if I do a pixel to pixel mapping, the image on my left hand side and the image on my right hand side are not the same, because the image on my left hand side is a side view of an elephant, and in fact it has two elephants in that picture, and the image on my right hand side is a front view of an elephant in a monochrome fashion. It is not even a colored one. When our human mind identifies both are elephant, because it doesn't go by pixel to pixel comparison, rather it takes up the features, it tries to understand all these features belongs to this particular class, or this is elephant's image. Whereas the earlier image algorithms which we started with our, when the computer was developing or the processor was coming, is we were trying to do one pixel to pixel. So that is the reason this type of complex processing cannot be done using your very base algorithms. You need to have an algorithm which will work as per what your human mind works. And human mind, trust me, is so complicated. Whether it is a zoomed in image, zoomed out image, it is a distorted image, it is a rotated image. Even if I rotate the picture by 360-degree, still your mind will identify that it is an elephant. The reason is simple. It is trying to do a pixel to pixel, it is not doing a pixel to pixel comparison, but it is trying to do a feature mapping. It is trying to understand what are the features an elephant possesses and what your eye has captured corresponds or it resembles to it. So that is the going in theory behind your CNN algorithm. So that is exactly what it does. So if I go on to the next slide, it talks about if I want to implement that algorithm, it follows two major steps. First, you need to break it down into a manageable vector, which I will show you how it is done. And number two, how do you do a weighing process? So any implementation of CNN which you do, whether it is on-prem or it is in cloud, these two factors are very essential. Without knowing this, if you are going to blindly implement it, it will be like just copy pasting the code, but without having a depth understanding on how you can go ahead and manipulate some of those parameters. Okay, so what we are going to do is we will take the same example of elephant and we will do a feature mapping. So a couple of features which I have taken in this slide is I have taken the trunk of an elephant as a feature. I've taken a head of an elephant. You can take multiple features, and more the features, your model will be much superior and which will be much of higher quality. If you reduce that features, for example, if I just take the head of an elephant, if any animal which resembles closely to an elephant comes into the picture, your model will incorrectly detect that animal as also as an elephant. So you need to have more and more features, but for the sake of this session and to simplify it, I'm just taking one of it, okay? So getting on to the next slide. So this is one example where I have taken an elephant and I'm putting it into 8x8 grid. So basically now a picture is converted into a simple 8x8 grid, and to do any algorithm, you need to convert that as a number. So what I will do is I will convert that into a simple cell wherein if that cell has any part of the elephant present in it, I will put it as +1. If the cell doesn't have any part of the elephant, I will put it as a -1. And similarly, I'm taking the ear of an elephant as a sample feature, and I also convert that as a 3x3 grid. So basically, if you see the slide, so in the very first, on your left-hand side, the ear of an elephant is mapped onto a 3x3 grid. And just beneath it, I have put in something like +1, +1 and -1. Basically, whichever cell doesn't even have any portion of that ear, I have made it as -1. Similarly, the 8x8 grid is also converted into a numbers depending upon the elephant which is present in that grid. So now what we have essentially done is we have taken an object, we have converted that into a grid, and for the sake of simplicity, I have made it as a monochrome thing. So I'm operating between -1 and +1. But in reality, it will be a high definition picture and the numbers will vary. But if we get into such complexity right for the starters or beginners, it will look too tedious or humongous task. So I'm keeping it pretty simple, saying that, okay, you just operate between your -1 and +1. Now, the first thing of your CNN is filtering. So I take the whole object, the 8x8 grid, and then I take the feature which I have taken, in this case, the year, and I scan that feature across each and every cell of this object. And whenever I see a perfect match, I make it as +1. And whenever I see a partial match, I put in whatever number it comes in. The number will be something between 0 and 1. The way it is calculated is I will superimpose that grid, which I have highlighted here as one example, and I will calculate the average of the cells. I will calculate the average of the cells so that here the grid is about 9 elements. So I will multiply all the 3x3 matrix against the grid which I'm mapping in, and then I will take the average of it. You need not worry when you do the implementation of the algorithm. You need not write the code for all these things. It is all well written, whether you follow AWS, whether you follow Google or any open APIs. All this is completely written. What you might need to do is you might need to just select a feature and describe that feature. More than that, you may not need to write volumes of code. That is one biggest advantage of Python and AI, wherein most of this complexities are being hidden from you or abstracted from you in terms of the libraries. So you have to just invoke the library. The rest of the things will be done for you. Anyhow, at the end of this course or this particular session, I will be showing you the implementation. So if you are someone who is little scared about coding, do not worry, you will not be asked to code for all these things. Okay, so it takes the grid, it scans over the entire object and tries to understand how that is completely matching or partially matching. The next example shows a partial match where in fact I'm running this grid against the head of the elephant, um, and it gets a partial match of 0.33. So in this way, the whole feature is taken across the entire the structure of the elephant, and this is what you get. And this numbers which you see was actually calculated. So when I run that matrix across the entire picture of the elephant, this is the matrix which I get only for the ear. Now I can repeat it for the trunk, for the leg, and for any number of features which you have. And what you get is a set of matrix, and that is called as your very first level of convolution. So what you have done so far is you have broken down that image into multiple features and formed a set of matrix. And that set of matrix is your very first layer of convolution, which is slightly larger in size because we started with the 8x8 grid with numbers between -1 to +1. Now, if you realistically see, I see that a lot of decimals are there. I see a lot of negative numbers are there. So basically, the size of the grid remains the same, but the computation has become heavy. In fact, if instead of using -1 to +1, if I have used numbers between 0 to 256, this grid would have become more and more complex in nature. So assume that I have 10 features which I'm using to map an elephant. I would have got 10 grids like this. So this is your very, very first layer of convolution. The second thing which you do is, as I said, this numbers or this particular uh, grid looks to be little unmanageable. So I want to reduce the complexity. So the way I will do it is, I will go ahead for some amount of compression, wherein this numbers will become little bit manageable to me. But before I jump on to that, just as a reminder to you, as I said, you will not be coding this, but rather you will be making use of the number of features as an input and size of each feature. And why do I have a car diagram in the slide is, it is a metaphor wherein when you are driving a car, not all the people understand the functioning of the combustion engine. But what they do understand is if they press an accelerator, the car will gain speed. And if they press the brake, the car will slow down. So those are technically called as controls. So basically, when you know a control of a machine, you will be able to control it even without having to know the internal working or the architecture of it. Similarly, in CNN, those controls are termed as hyperparameters. So any deep learning algorithm which you may choose, not only CNN, anything in future, you will come across this word called as hyperparameters. Hyperparameters are nothing but your controls which are similar to what you see in the car. And those are the parameters which you need to provide input or calibrate up and down depending upon your model's expected efficiency and accuracy. So in our case, the hyperparameters so far is how many features you want to select and what is the size of the each feature or the filter. So that is the two hyperparameters which you need to definitely provide irrespective of whichever implementation you choose for the CNN. Okay. So now coming back to our point, we landed up in a very big matrix and we wanted to compress it. There are many compression algorithms or compression blocks available on the market, but the simplest of it which we use is something called as max pooling. In max pooling, the idea is very, very simple. You select a grid and take the maximum number of the grid and write it to the resultant grid. So basically, if you see the one which I have on the slide, the upper left-hand corner has four numbers, 29, 15, 0, and 100, out of which 100 is the max. So in the resultant matrix, I choose 100. And the same thing applies to the rest of the grid as well. And the other types of pooling which is available is instead of max, you can go for minimum pooling, or you can go average, or if you are statistically more inclined, you can go in for the mean, standard deviation, and other things as well. But that again increases your complexity and it might take you off the mark. So to keep it very, very simple, I'm selecting a max pooling wherein I will feed in the input vector, and the output grid will have the maximum number in each of the grid which I have selected. So obviously here it is a 2 cross 2 which I'm choosing in, and this is how I get a output. So if I choose the numbers which we had out of the elephant and I apply a max pooling, this is the resultant vector which I get in. Again, this is computed manually, and you can repeat it in your free time as well to see how did you arrive at this vector. So all this exercise, whatever I have done so far, can be done manually without even you needing to get onto Python or anything else. Now, the hyperparameters for this block is your grid size and how much you stride. How much you stride in the sense, if I go back to the slide, what happens is, if you really see, if I apply 2 cross 2 grid, that is the reason I have colored it. So 0.33 and 0.55, that first row and second row forms your first stride, and the subsequent two rows, negative 0.11 and plus 0.11, forms your second stride. Then you have a third stride of 0.55 and minus 0.11. But when it comes to 0.77, there is nothing beneath it. So what we do is we go ahead and take those two rows alone, assuming that the other two rows beneath it is 0 and 0. So that is how we formed the resultant grid. And once we have formed it, now you will get a very compressed matrix, which is more manageable than the cumbersome one, which you just got out of your first layer of convolution. Now, the hyperparameters for this is simple. It is your grid size and the number of strides which you want to do it. Now with that, you have done your first layer of convolution, then you have done your pooling and you have formed a matrix. Is that the whole thing? Ideally, I would have chosen to say yes, but actually it is not. So if you really see, we have to go through a concept called normalization. What I meant by normalization is, if I have to tell in terms of students example, there might be a case wherein some of the staffs are too lenient. They try to score, they try to give liberal marks, and some staffs might be very strict in nature, and getting 80% from them is good as getting 100% with another staff. So depending upon each of their mind, the way they approach, your marks may differ. So what normalization does is it tries to arrive at a neutral point, so that if a person is going to go through a correction of a staff who is very lenient, and other student goes through a staff who is very firm, the liberal nature and the firm nature shouldn't impact the students. So they tend to normalize it at a higher level. So in your way, in your language, if I have to say, it will be a percentile calculation depending upon the scores which every student has got in an examination. They may come up with a percentile one, saying that how much you have scored against in the class. Similar to it, we will have a concept called normalization in CNN, wherein we will be compressing this matrix further to take all the negative numbers. If you ask me why it is essential, the example which I have given in the slide will explain. So assume that you have built an algorithm for identifying or classifying an elephant on all the examples which you have fed into the algorithm or Indian or Asian elephants, and tomorrow your model is being fed with an African elephant, the picture of an African elephant. Asian elephant and African elephant are not the same. They slightly differ, but because of the difference, we don't want the model to go ahead and start retraining itself and start recalibrating itself, because end of the day, both are elephants. The slight technical difference shouldn't cause a lot of training effort and recalibration effort. So to avoid that, what we do is we normalize it. Or in simple terms, if I have to give you a different example, assume that you have trained your algorithm with all the, say, for example, all the cats pictures which you have at home. and all the cats belongs to the ginger category where every cat is brown, and all of a sudden your model has to classify a cat which is black in color. Just because the color changes, the model need not go ahead and retrain itself. So to avoid this type of minor variation triggering a complete set of uh, recalibration and retraining, we go in for normalization. So in simple terms, what I do in normalization is I take the grid which came out of the previous step, and wherever I see a positive number, I retain it. And wherever I see a negative number, I convert that as a 0. So statistically, what does it mean is it, it limits your variation, it limits your distribution, so that this type of small negative variation doesn't induce a complete retraining of your job. So we have seen three things. We saw filtering, we saw pooling, and we saw normalization. And these three things need not be done just once. It can be done subsequent to each other like a chain. And once, if it is done in series of chain, then what you get finally, that is called as your resultant vector, which is the base or the end of the phase one. So you keep repeating it, and then you form finally, if you see in the slide, this is the compressed and the least possible vector which you get for each of the features. And the reason why I had this sandwich picture here is to give you an example. This steps of convolution and normalization and pooling need not be just done in one sequence, but the output of one can feed into the other, and it can be repeated a number of times. And this is what you get as a vector formation as your very first step. But remember, we are just halfway done. With this vector, you are very close in classifying an image, but you are not yet there. And still, this vector will not tell you whether it is an elephant or a giraffe or a zebra. But what you have done essentially is taken a bigger picture, broken it down into grids, and then worked your way by applying different techniques, and then have compressed it to a size which is bare minimum, beyond which you cannot further reduce it. Okay. So fundamentally, now the problem which you started with is has converted into something like this, where you have an input vector and something called as a black box, which should help you to identify your output. The three classifications which I just showed you at the beginning of this session, and now we need to figure out what is this black box. And if you are wondering, how did I get this input vector? I have not done anything, but whatever you got in the previous slide, I have just written down in a linear fashion. So I have not changed the numbers, but rather than having that as 2 cross 2 grid, I have converted that into one linear array. So this is my input, and I have an output where I need to classify it as one of the images which I have listed it down. And I need a black box which will help me to do it. So in simple terms, this is as good as I have the features. Now I have the output. I need to understand all these features belongs to which of this particular organism. And by doing this, you have removed the bias which occurs due to the zoom in, zoom out. You have removed the bias which occurs due to your distortion or rotation or any type of image denting process. So that is something which is as equivalent as your eyes identifying the object. So this is where you stand now. And the next step is going to be a little interesting. So the next step is where we are going to build a set of neural network, a set of neurons, which will help you to identify one of your outputs. So you know your input, you know your output. Now we are going to form a set of hidden layers through which you will understand which output it is. And to begin with, it will look very confusing. So I want to take you through a metaphor and help you to understand the concept, and we will come back to this. if I take you to a metaphor, this is something like a bridge. If you are in Chennai, you would have seen the Katipara Bridge, which is technically called as a butterfly bridge, which has so many exits and so many entry points. But assume that you get on the bridge remains the same depending upon wherever you want to go. You want to reach your residence, or you want to go to Coimbatore market, or you want to reach to a friend's house. You know where to exit out and where to enter. So though the bridge remains the same with multiple exits and entries, depending upon your destination, you take the appropriate exit and come out of it. Similar to it, the neural network which I've been speaking about will have multiple outputs, but depending upon the input vector, it will choose one of the path and will go ahead and stand exactly at the output. So what I mean by that is, so let me show you a little bit more detailed example and you will understand that. So the first layer of input is called as your neuron, and then you start building up more and more neurons, hidden layers. And to each of the neuron, you will connect it with a weight. And this weight, to begin with, if you are a starter, you will assign a random number. And you might ask, what is the fun in assigning a random number? But believe me, that is how it gets started. You will assign a random number, and then you will arrive at each of the neuron and form a path. So for example, if you have chosen uh, the image which I have given, and by your random numbers, if it identifies the input as incorrectly as a giraffe, in this case, it is all labeled output. So you know for sure, hey, this is not a giraffe, this is an elephant. So then you go back and you keep changing the random numbers in a way until the confidence limit of elephant goes up and confidence limit on your output as a giraffe goes down. And this recalibration continues to happen until, for a given set of inputs, a training input, your model correctly goes ahead and stabilizes in the right output. Because in this case, you know it is an elephant, it is a known classification, you will go ahead and keep meddling with your inputs. You will keep meddling with your weights such that until for all the inputs which you have given, it stabilizes to a elephant. And similarly, then you will change the input features of a giraffe and see whether the confidence limit of a giraffe is reached and the other outputs are reduced. And this is not something which I want you to just understand. After this session, if you go to a site called, you go to Google and type out saying the TensorFlow Playground with the keywords which you have given, you will get to you get your hands dirty on it. This is a free tool which is given by Google, wherein this type of you can provide a feature, and at the top you can see a play button. When you press the play, it will take you through multiple iteration, wherein the output which you see on the right hand side will converge to the to the minimal error possible. And when the curve flattens out, that means that for that set of input, that is the optimal performance which you can get. And then you can change the model by providing more and more inputs. Instead of x1 and x2, you can make it as x3, x4. Just click on it. You need not do anything else. And when you click on the lines, the weights will be displayed. You can go ahead and edit the weights as well. This is a completely free tool. It runs out of JavaScript, and it is something which I will recommend all of you to go ahead and make a try. Even if you don't have any account on your GCP or anything, this doesn't need anything. It is absolutely free and you can try a number of times. So what it does is it takes inputs, and for a random set of weights, it tries to converge as an output for a with a minimal loss functionality. And what I will recommend you is just see how many iterations it takes to reach a optimal output. If you provide more and more features, it will reach optimal output in a very less number of iteration. But if your number of inputs is very less, it may take multiple rounds to reach an stability. Similarly, if you keep increasing your hidden layers which is again a button which is provided there. You can click on that. As your number of hidden layer increases, your output also will become more efficient in the lesser number of iterations. So basically, either you can increase the number of features or you can increase the number of hidden layers. But in a perfect AI world, increasing the number of input features is the most recommended one, because as you keep increasing the hidden layers, the model will work fine. Your loss will be minimal, but it undergoes a concept called as overfitting. So what really happens is it works only for the data set which you have provided. And if you give a similar data set, not the same, but similar data set with the same type of distribution, it will error out or the loss will be more. So you need to maintain your hidden layers somewhere between 10 to 11, depending upon how many inputs features you have. And then also try to reduce your epochs, because in real world, getting data is the most difficult thing. But if it is a random objects or something which you see in real time, which is fine. But if you are someone who is going to analyze the tumors, if you want to provide x-rays and make a machine to understand whether a person has tuberculosis, whether he has a malignant tumor, or whether the heart is not functioning well, getting so many images of your lungs or a heart or other things, right, is not going to be very easy in the real time world. So if you are someone who is getting on to training your model on the medical history, remember the major challenge which you will have is not building a model, but fetching the right quality of data. So that is the reason when your data is limited, the best bet on that is increasing the number of features. So how many divisions you can make of the lungs or the heart and train your model on each of that specific segment will determine your success. But I don't want to jump on such complex things when you are just getting introduced to CNN. But I also want to tell you that the challenge which we face in the industry is not really building the model, because we have so many APIs, but getting the right data, cleaning the data, and imputing the data, that is something which takes majority of our time. Okay, so probably after this session, I will recommend you to go ahead and try this TensorFlow playground, and I definitely believe it will keep you engaged. But coming back to our theory part, what really happens is the way we wanted to iterate that model is until a point wherein the model flattens out or the loss function is minimal, or in analytical term, this is nothing but called as a gradient descent. So you have a curve like what I've shown in the diagram, and at the point x2 is where the slope of the curve is 0. So any change from that point will either increase your error or it will remain as 0. So that is the point which we want to figure out, because that is the most optimal point for any machine learning model to function. But we will not be knowing the gradient or the 0 gradient to begin with, because that is the challenge. That is why we have to do multiple iteration. And the analytical way of doing that is assume that you are in a point x1, and now you increase your input. What really happens with the error? If the error rate goes down, that means that you are traveling in the right direction. If the error rate goes up, that means that you are traveling in the opposite direction. So it will tell you whether you are doing the right thing or not, but it will never tell you where is the point of 0 gradient. So we keep traveling, traveling, traveling until it reaches the 0 gradient. But when we do it, we can do it in increments of least number of steps or higher number of steps. If you do it in least number of steps, the number of iterations will be more. And for each iteration, there is an amount of CPU which is being utilized. And if you are going to use cloud, for every iteration, there will be a bill which will be tagged to you. And if you're going to do in a lesser number of iteration, that is bigger steps, you might miss out the 0 gradient and get on to the other side of the curve. So in technical terms, that is called as the learning rate. So when you want your model, when you are building up your model, you want your learning rate to be in such a way that you don't miss out on the zero gradient. That is going to be very important, because the moment you miss out, your model will still function, but it is not functioning at an optimal rate. So you need to ensure the incremental steps are taken care in a way that the zero gradient is being covered. And that is what I will recommend you to do it in your TensorFlow Playground. To see, when you click on the play button, just above that graph, you will see a curve which is coming up, and slowly that curve will flatten out. Then beyond a point, it will it will be stable. So that means that it has reached a point of zero gradient, and that is the exact point at which you want your model to work, right? And that is going to be the most interesting challenge for any AI engineer to figure it out. And remember, in a practical world, this doesn't remain constant. If your number of input changes, or if your variant of your graph changes, in my case, I have assumed that there is only one uh, optimal point of zero gradient. But what happens if it is a sinusoidal wave? It's something like a sine wave, where for every alternate cycle there is a different gradient. So those are few things which you'll see in the practical world, but that is something for an advanced session. I will not cover it right now. But remember, this doesn't it's not straightforward as it seems. It has its own set of challenges. Now, coming to your implementation, if you want to go ahead and do an implementation of what you have learned today, right away after this session, I will recommend you to either download YOLO. YOLO stands for you only look once, or TensorFlow. Both are open source, both are free. You can download it, and they have a very simple example which has the implementation of CNN. I will give you the source code in my GitHub as well. But the only challenge is, it depends upon your machine speed. If you are using a machine which is little outdated, or which was just used to watch movies and to check mails, your CNN will not work on it. If you have a machine with the minimum, you need to have your GPU, which is primarily people who are into gaming. If you are having a laptop which wherein already you are playing games and other things, that is the machine which you need to use for your CNN. If you are using your normal laptops, trust me, your TensorFlow itself, the version 2.0, will not even get completely deployed. It requires your GPU, and it requires your advanced processor, Intel Core i7 and above. Don't even think about Pentium versions. With the Pentium dual core and other models, it will hang and the job will run forever. And you need to have a Python minimum version of 3.5 to 3.8, and Windows 7 or later, 64-bit, which is a minimal configuration which I have highlighted here. Absolutely, you need to have your GPU. So there are certain softwares which comes without GPU, which can work with CPU alone. But what I have seen practically is, it will not be able to do all form of image classification, number one. Even whenever it does, it takes a lot of time. I personally have an experience where I submitted a job. I did all my domestic work. I had my dinner, I came back, and the job was still running. It reminded me of my mainframe days, wherein we used to submit a job, we used to go out for a coffee break and come back, and the job will be still compiling. So if you are planning to do a on-prem implementation, these are the minimum configuration which you should have on your desktop or laptop to do it. And if you are a person who is very much willing to learn CNN or a deep learning, but you may not have all this advanced configuration, then what you do is go to the cloud implementation. Cloud implementation, you might be uh, paying a small sum for each of your job which is being run, but it is still better because you'll be paying only in few hundred rupees, not in thousands. For me to run this algorithm, which I'm going to show you in next few slides, it cost me around 220 rupees for each iteration, because I'm using so many resources for it. But remember, if you are not someone who is not used to the cloud, don't even attempt it, because if you leave a particular resource in a open condition, it will keep piling up to your bill each and every day. So, and depending upon your cloud proficiency, you can do it. So one of the things which I normally make use of in cloud is SageMaker. SageMaker is a service, is a AI ML service which comes from AWS, and this is used for all such algorithms. In fact, you need not code any of it. All these algorithms which I just told you, they have this implemented in form of a container images. You just need to call that image and provide your training data set, and then you go ahead and run the job. You will get a model, and you can configure an endpoint to that model and start using it. So if you are someone who is very confident on the cloud and have a hands-on the cloud, either you go to AWS cloud. In that case, you can make use of a SageMaker, or you can make, if you are comfortable in GCP, go ahead and make use of GCP Collab. So there are many ways of doing it. You have YOLO, you have TensorFlow, you have SageMaker, you have your in fact Keras is one of the open source API which can build on, which can run on top of your TensorFlow and other algorithms. It is absolutely free of cost, but you need to decide where you are going to implement it depending upon what type of machine you have. So I'm going to show you the AWS implementation. So go to the AWS console. If you type SageMaker, you will get something like what you see in the screen. There, if you see the notebook instance, if you click on it, you will, on the right hand side, you will see a console. And this, once you click on the notebook instance, it will launch a Jupyter notebook, which is very similar to what you see in your Anaconda. So it will launch a Jupyter notebook, and then you will be able to go ahead and put the code. So for this example, which I have given in this PPT, is taken from a set called as, this is from the Caltech University. So what they have done is they have taken roughly 30,000 images of the objects which you see in the day-to-day world, your baseball, your water bottle, so many things, whatever you see around you, they have taken 30,607 images. It is a 1.2 GB file available free in Kaggle. So if you go to internet and type Caltech images, you will get it. And they have classified this 30,000 images under 257 categories. Basically, it is 256 categories. The other last category is for the clutter, wherein it is unclassified. So basically, you are not able to put in any of these categories. They have put it in the clutter. And this data set is what I have used for this particular lab. So I'm taking the data set and I'm converting that, and I do a data preparation by converting that into record IO protobuf format. That is as simple as JSON. In JSON, you will have the complete description of each of it in the JSON itself. So what I mean by that is, assume that I want to build a JSON for name, age, and your department. So I will have name, colon, your name, and age, your age, and the department will be ECE, triple E, or whatever it is. But in record IO format, instead of doing that, I will convert that as a schema and make it as a header, saying that all the records will follow this schema. It will have a name, it will have a age, it will have a department, and following that, the record will have just the values. So basically, I'm trying to avoid the overhead for each of the record and centralizing it as a header. And most of your SageMaker jobs, they run it in the record IO protobuf format. And that is what we do here. And I classify that as a test job and training and a validation files. Normally the ratio which we choose is 80-20, but in this case I've chosen 60-40 because the images, too many images were there, and there are too many classification. So out of 256 classification, randomly we chose 1,000 images and made it as a validation file. The rest of it we left it in the training file. And once it is created, I loaded all that in S3, which is your storage option. And these are the hyperparameters which I had been talking about, the inputs which you need to provide to any implementation. It talks about how many layers it has, how many images in total you have, and how many iterations you want to go, and what is the learning rate. Do it in the increment of zero point zero 0.01 steps, and what is the each batch might contain. So you are free to specify these numbers. So depending upon whichever data set you have chosen, since I have chosen a Caltech image, I chose the number of classes 257 because there are 256 categories and one clutter category. And I have chosen the number of layers is 18. So basically, the number of hidden layers which I form in the neural network will be 18, and I'll undergo 2 epochs, which will be 2 iteration. And remember, every iteration you make, it means that there will be additional resources which will be utilized, and it will be charged against your card. That is the one thing which you need to remember whenever you are doing in the cloud, whichever cloud you may use. Need not be Amazon. Even if you use your Google or anything of that sort. And once it's all done, when you submit a job, it will it will create a training job. And training job is something which you can keep iterating until you reach your minimal point, the point of zero gradient, by changing your hyperparameters. And if you are not someone who are comfortable changing hyperparameters, AWS gives you an option to auto tune the hyperparameter and select the best model for you. So it will run parallelly multiple training jobs with different inputs, and then it will tell you that for this combination, this is the best model you can get. And then you can configure that model. Don't worry about the code. All this code is there in GitHub, and I'm making it absolutely open to all of you. Okay. And once you have configured the model, you can create an endpoint, and then you upload any object. The model will detect and tell you that this object is so and so. So if you just click your pen and upload that image, it will tell you it is a pen. If you click on a laptop, it will tell you it is a laptop. So as long as the image is one of the 30,000 images which Caltech has taken, it will tell you. But if you are going to take a picture of your Raspberry Pi or anything, right? It may not even tell you, because Raspberry Pi or your Arduino, those are the things which you don't see in the real day-to-day world. It is all restricted to your IoT and other sessions. So in such cases, what you have to do is you can go ahead and annotate the image. So if you have very custom image which is not part of the data set, AWS provides you option to annotate it. Either you can do it using your JSON if you are good at it, or it gives you a feature called as ground truth, wherein you can ask your friend to annotate it, or you can have anyone to do it. That is the case which the French government used today by identifying the people in mask, because people in mask was not a common category before COVID. So now they collect, internet has a data set with mask, people with mask. They downloaded it, they annotated it, saying that this is what a mask is all about. So the model will learn, and then if you provide that particular objects, it will classify it. So this is how it is done. But remember, again and again, I'll tell you, if you are using cloud, be absolutely clear to terminate all your resources, because it charges you per billing second, depending upon what type of resource you are using in. Okay. So, and if you have any questions around the the logic which I have provided or the code which I have provided, feel free to approach me. But before I wrap down the session, I also want to tell you, it's not that CNN is a is a algorithm which will solve all your problem. It is only applicable as long as the data follows a spatial pattern. What I mean by spatial pattern is it follows a structure. So if you take a US map, whether it is a physical map or whether it is a political map or whether it is a weather map, the structure remains the same. Florida is in East Coast and California remains in West Coast. As long as the structure remains the same, classification can be done. But if the interchanging of structure, the CNN will fail. So in case if you have 10 records of your student making use of CNN will not work. In simple terms, if I'm going to show it an image which has an elephant, but with a black and white stripes on it, that is not the real structure which we used to see. In such case, CNN will fail. So CNN is suitable only for those images which follows a spatial pattern, and it takes so much of computation. So much of computation. That is the reason I said you cannot practice deep learning algorithms in your normal laptops. Either you go for a specialized laptops or you go with your cloud. These are the two choices which you have. And I know that I have been talking continuously. I didn't see the what is a chat session. If there are questions around it, feel free to let me know. And these two things I have also elaborately put it in as a blog and videos. You can have a look at it offline. It is available in a YouTube channel called Tech Padasala. You can see that. So let me take a pause. Over to you, sir. Any questions or anything, let me know.
Thank you, sir. It was a wonderful session on convolutional neural networks. I'm sure we are receiving queries. We will forward the same to you. I now take this time to reiterate a few instructions. There will be no quiz today at the end of the session. There will be a quiz held tomorrow from 4 to 5 p.m. Those who score above 65% will be eligible for merit certificates. And please note the quiz link will be active only for 1 hour. So all are requested to take up the quiz between 4 to 5 p.m. tomorrow. The link will be shared in the Telegram group. The participation certificate will be shared within a week's time. And I also request all participants to kindly pay attention while filling names in their Google Forms, as these names are directly used for the certification process. And there were some queries on the materials. That is, some participants wanted the materials. So these materials will be shared through mail. All further updates will be posted through the Telegram group. I now request few participants to give us their valuable feedback. I first call upon Mr. K. Chittibabu from RMK Engineering College to give his feedback. Please, sir.
Very good afternoon. I attended all the 5 days, and the total webinar was excellent. The contents delivered was very nice, most useful, and knowledge sharing. And the presentations made by all the resource persons were very excellent. Overall, I feel that I gained a lot of knowledge through the webinar that I attended all these 5 days. I thank the whole team, organizing team, and every members of this team for organizing such an excellent webinar. Thank you.
Thank you, sir. I now call upon Dr. Manivannan Kalayappan, CEO, Muhammad Satak, AJ College of Engineering. He is a National Expert Advisory Committee member, NCSTC Division, DST, Government of India. He's also Vice President of International Federation of Engineering Education Societies, and he's a Chairman of Global Engineering Dean Council, India Chapter. Please, sir.
Hello?
Yes,
sir.
sir.
Audible.
Audible? Okay. Thank you, the JPR Institute of Technology. In fact, it's a well planned and organized data science 5-day FDP for all the faculty. In fact, very well organized and very well articulated by all the experts, starting from Mr. Bala and Shivashankar and Mr. Neelakandan and Kode Nachyar and Durga Ratnasamy and Vivek Chaudhary, and today the Sami Narayanan. It's a wonderful thing. In fact, I also learned what is exactly data science, even though I'm a mathematician come computer science man. I want to learn, and in fact, I got a lot of insight about data science and their application. In fact, Kodai Nachar has very well articulated what are the various research and development, all those things. I must appreciate the efforts by the director, Dr. Maria Wilson, as well as the team of Department of Information Technology, and the coordinators, especially the Nancy or Sonia, no? Who is the name? Sonia and everybody for the
all the team members.
For all the team. Excellent. In fact, very well organized and very well planned and executed with both theory and as well as the Python programming and all those things. Wonderful FDP. Thank you, and hope the JIT is going to come in a very different way, because within very 10 years of existence of institution, we have done a lot of innovative methods and practices for the betterment of the faculty as well as students. All the best for you. Thank you.
Thank you, sir. I would now call upon Ms. Mageshwari, HOD, Department of Information Technology, DMI College of Engineering, to give her feedback.
Good morning to one and all connected to the online FDP. I am really feeling delighted to take part in the online FDP on emerging technology and data science, which is organized by Department of Information Technology, JPR Institute of Technology. In this FDP covers a wide range of concepts, starting from foundation of data science, basics of Python, data visualization, model building, and some of the machine learning concepts, which is an eye-opener to carry forward the research. Overall, we enjoyed and learned a lot in comfortable environment, and the style of explaining the concepts and the knowledge of the resource person were totally amazing. It is not an easy job to cover the hands-on session as well as the demo in the online, even though you did well. I would like to thank the organizers for the tremendous effort and wish you all the best with that. Thanks for giving the opportunity to attend this 5 days online FDP. Thank you once again.
Thank you, ma'am. Now I request our beloved principal, ma'am, Dr. L.M. Merlin Livingston, to speak a few words. Please, ma'am.
Good afternoon to all. I am very happy to see the overwhelming response of the faculties and students from various institutions across India. Hope you all had a very informative session. First, I want to congratulate all of you for participating in the 5 days faculty development program during this current situation. I thank Dr. N. Mary Wilson, Managing Director of JPR Institute of Technology, for his motivation for the success of this program. I thank Mr. S.P. Balamurugan, CEO and founder, GUVI Technologies, technology partner of this data science program. Thank you, sir, for your constant support. I thank the speakers, Mr. Shammy Narayanan, AVP-AI Practice, Ms. Gausalya Kode Nachia, Certified Blockchain Expert, Amtech Systems, Ms. Durga Ratnaswamy, Data Engineer, Manager at PayPal, Mr. Saudar Elumalai, Senior Data Scientist Consultant at SAM, Dr. Shivasankar Sugumar, IIT Gandhinagar. Organizer and speaker of our college, Mr. Neelagandan, for sharing their knowledge to make the sessions more lively. Congratulations to Dr. R. Annamalai, HOD of Information Technology, and their team of faculties. I wish the participants to do more innovations through data science. Once again, I thank all the participants for making this event a grand success. Stay home, stay safe, be active, continue your learning. Thank you.
Thank you so much, ma'am. I now call upon Mr. R. Annamale, HOD, Department of Information Technology, JPR Institute of Technology, to deliver the vote of thanks. Please, sir.
Good afternoon to one and all present here. Hope you all enjoyed the 5 days FTP session on emerging technology on data science using Python, which was held between 18/5/2020 to 22/5/2020. I feel elated to propose this vote of thanks on behalf of JPR Institute of Technology. I would like to thank our beloved Managing Director, Dr. N. Maria Wilson, for his constant support and encouragement and for providing us with all the needed resources. I would also like to extend my heartfelt gratitude to our principal ma'am Dr. L.M. Merlin Livingston, for her motivation ever. I extend my sincere gratitude to our technical support team, GUI, Mr. S.P. Balamurugan, and I would like to, I'd also like to thank all the speakers for making this program a successful one. Most importantly, my special thanks goes to all the participants and their institutions who have given us a way to attend this FTP. I would also like to thank the faculty and students community to take part in this FTP. The 5 days FTP on data science was conducted successfully, and it was being live streamed in YouTube, and we had 4,500 participants from across various colleges and country. I congratulate the active participants and the winners of the quiz. I would also like to thank the organizing team for making this program a grand success. Without making a full stop from this vote of thanks, one more announcement here to all the participants. We, the JPR Institute of Technology, happy to announce that we have planned another 3 days FTP on cyber security, hands-on, probably by next weekend. So the participants who are registered in Data Science FTP will get an invitation link. Kindly join with us to learn the new technology. And I'll thank each and every one who make this function a grand success. Thank you. Thank you to one and all.